In this video, we will explore system monitoring using SAR, which stands for System Activity Reporter. It is a powerful tool for collecting and analyzing system performance data on Linux systems. We'll cover how to use SAR to monitor CPU usage, memory utilization, disk input, output, and network activity. This will help you understand how your system resources are being utilized and identify potential bottlenecks. So what exactly is SAR? Well, SAR stands for System Activity Reporter. It is a command line tool that is part of the Sysstat package. This package is commonly found on most Linux distributions. SAR collects, reports, and saves system activity information. It allows you to perform historical performance data analysis, which means you can look back at how your system performed at specific times in the past. SAR can monitor various aspects of your system, including central processing unit, memory, disk input, output, and network activity. By monitoring these components, SAR helps you identify system bottlenecks, such as high CPU usage or slow disk input, output, that could be affecting your system's performance. Now, let us look at the basic usage of SAR. To install Sysstat package, use the command sudo apt install sysstat. To get a basic central processing unit usage report, use the command saru15. To view historical data, the command sarf/var/log/sysstat/sa01 is used. Let us see how to monitor central processing unit usage with SAR. Here is the command. The command saru23 monitors central processing unit usage every 2 seconds for 3 iterations. Now let us see the sample output. Here we have the header indicating it is a Linux system. It also displays the date and the number of central processing units. The output shows the time CPU and percentage of user time, percentage of nice time, percentage of system time, percentage of input, output wait time, percentage of steal time, and percentage of idle time. The average values for all the parameters are also displayed. Let's understand the central processing unit metrics. The key central processing unit metrics include %user, %system, %IOWait, and %idle. %user is the percentage of central processing unit used by user processes, meaning the applications and programs you run. %system is the percentage of central processing unit used by kernel or system processes, which are the core functions of the operating system. %IOWait is the percentage of time the central processing unit is waiting for input-output operations, such as reading from or writing to disk. %idle is the percentage of time the central processing unit is idle, meaning it's not being used. Let's look at some advanced central processing unit monitoring techniques. To monitor per central processing unit statistics, use the command sarp-all13. To show central processing unit utilization by process, use the command sarx13. To monitor central processing unit frequency, use the command sarmcpu13. To monitor context switches and interrupts, use the command sarw13. Now let's discuss how to monitor memory usage with SAR. Here are the commands. The command SAR-R23 monitors memory usage every 2 seconds for 3 iterations. The command SAR-S23 monitors swap space usage. Let us see a sample output. Here is the header indicating it is a Linux system. It also displays the date and the number of central processing units. The output shows the time, kilobytes of free memory, kilobytes of memory used, percentage of memory used, kilobytes of buffers, kilobytes of cached memory, kilobytes of committed memory, percentage of committed memory, kilobytes of active memory, kilobytes of inactive memory, and kilobytes of dirty memory. The average values for all the parameters are also displayed. Let's take a closer look at some key memory metrics. The key memory metrics include kilobytes of free memory, percentage of memory used, kilobytes of cached memory, and kilobytes of committed memory. Kilobytes of free memory indicates the amount of free memory available in kilobytes. Percentage of memory used represents the percentage of total memory that is currently in use. Kilobytes of cached memory shows the amount of memory being used for file system caching, which helps improve performance. Kilobytes of committed memory indicates the amount of memory needed for the current workload, including both physical memory and swap space. Let's explore some additional memory monitoring examples. To monitor page faults in page ins or page outs, use the command sarb13. To monitor huge pages usage, use the command sarh13. To monitor slabs usage, use the command sarv13. To monitor swap statistics, use the command sarw13. Let's explore how to monitor disk input/output with SAR. Here are the disk input/output monitoring commands. To monitor block device activity, use the command sard23. To monitor individual disk activity, use the command sarpd23. Now let us see the sample output. Here is the header indicating it is a Linux system. It also displays the date and the number of central processing units. The output shows the time, device name, transactions per second, read kilobytes per second, write kilobytes per second, discarded kilobytes per second, average request size, average queue size, average wait time, and percentage of utilization. The average values for all the parameters are also displayed. Let's see how we can perform network monitoring using SAR. Here are some network monitoring commands. The command sarn13 monitors network interfaces. The command sarn13 monitors network errors. The command sarntp13 monitors transmission control protocol statistics. The command sarnudp13 monitors user datagram protocol statistics. Here are some key network metrics to look out for. rxkB/s and txkB/s represent the number of packets received and transmitted per second, respectively. rxkB/s and txkB/s represent the amount of data in kilobytes received and transmitted per second, respectively. Percentage interface utilization is the network interface utilization percentage. Active per second and passive per second represent the number of active and passive transmission control protocol connections. Let's explore advanced SAR usage and some best practices. Some best practices include establishing performance baselines. This involves monitoring your system under normal conditions to create a baseline for future comparison. Monitor regularly during peak hours to identify performance bottlenecks during periods of high demand. Correlate metrics across subsystems to understand how different parts of your system affect each other. Archive historical data for trend analysis to track performance changes over time. Use SAR in conjunction with other tools like TOP, IStat, and VMstat for a more complete view of your system. Automate monitoring with cron jobs to collect data regularly without manual intervention. Here are some advanced usage examples. You can configure data collection in the /etc/sysstat/sysstat file. To generate hypertext markup language reports with SATF, use the command satfd/var/log/sysstat/sa01 ursatfh report.html. To extract data in comma-separated values format, use the command satfd/var/log/sysstat/sa01 urndv-data.csv. To view all available metrics, use the command sarA11. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.